Okay, so we're going to go through just a couple of vocabulary words that are important to know for this unit. We're not really doing that much different calculation-wise. We're just going to kind of give some names to some things. So the first thing is percent yield. Basically, this is percent yield. We have a formula, and this is on your reference sheet too, on that page 145. But it's kind of up towards the top. It's basically like how much did we actually produce over how much did we think we could produce, or theoretical, and then we'll just multiply that by 100 to get our percent. So for the first problem, I already have the balanced equation in there, okay? And so it says that I want to determine the percent yield when this 77 grams are formed from burning 4 moles of oxygen. So this is my form, this is my product, this is my actual amount. Okay, this is how much is actually made. What I need to do is figure out my theoretical. So I'm going to start by just doing the same thing that we did yesterday, starting with 4 moles of oxygen. So now I'm in moles. I can use my mole ratio to convert to CO2. So if I look back up at my equation, I have an 8 in front of the oxygen, and I have a 5 in front of the CO2. Okay, but since I have grams, my actuals in grams, I need to keep going. I have to convert my moles to grams. So 1 mole of CO2, how many grams are in that? I just have to add everything up. So I'll add my the 12 grams from carbon plus 16 from oxygen, but I got to add that twice. So I end up with about 44 grams of CO2. So I'm just going to multiply everything in my calculator, multiply the top, divide by the bottom. 110 grams of CO2. So this is my theoretical. I'm going to change colors. So now to do my percent yield, I'm going to take my actual, which was, I actually made 77, which is a little bit less than what I thought I was going to make. So I want to know, how well did I do? How much did I actually make in this reaction, percent-wise? So when I type that in my calculator, 77 divided by 110 times 100, I end up with 70%. So my percent yield of this reaction is 70%. Okay, so we'll do the same thing down here. Okay, so this equation's already balanced. Everything's just my invisible ones. So here it says determine the percent yield of the reaction when 47 grams of calcium hydroxide is produced. So this is my actual. Okay, and I began with 39.27 grams of calcium oxide. Okay, so since I'm in grams, I have to go to grams to moles before I can get to use my mole ratio. So how many grams of CaO are in 1 mole? I'm just going to add up from my periodic table. So calcium is 40.08, oxygen's about 16. So I get about 56.08 grams. Okay, so that's canceled out my grams here. Now that I'm in moles, I can use my mole ratio. So how many moles of calcium oxide does it take to make how many moles of calcium hydroxide? So I'm just going to look up at my coefficients. So 1 and 1. So now I'm in moles of calcium hydroxide, but now I need to go to grams. So how many grams are in 1 mole? Okay, so I'm just going to type it in my calculator. So I have about 40 grams for calcium, 16 for oxygen, but I have 2 oxygen because of this subscript right there. And then I also have 2 hydrogens, so that's about 74 grams. So when I go through, multiply the top, so I'm going to do 39.27 times my 74, divide by what's on the bottom. And remember, the ones I kind of can just ignore. I get 51.8 grams of calcium hydroxide. Okay, so if I want to do my percent yield, remember this is my actual over my theoretical. How much did I actually make, which was 47, over how much did I think I could make? How much did the math tell me I could make? Okay, and then we're going to multiply that by 100. So 47 divided by 51.8 times 100. We did a little bit better on this one. Got about 91%. Okay, so that means that in the lab, when they did this reaction, they actually produced 91% of what they thought they could, which is better than these people. They only made about 70% of what they thought they could. So something might have gone wrong in their reaction or in their process where they kind of lost some of their product. The next term that we need to talk about is just what is the limiting reactant. So we want to know what this term means. It's easy to kind of remember it if you think about s'mores. Okay, so if I want to make one s'more, okay, I need 2 graham crackers, I need 1 chocolate, and I need 2 marshmallows. Okay, so what if I tell you that we have 4 graham crackers, 2 pieces of chocolate, and 2 marshmallows, right? How many actual s'mores can I make, right? Well, I've got graham crackers, should be able to make 2. Chocolate, I should be able to make 2, but then I look at my marshmallows, and I've only got 2, so I can't make but just 1 s'more. Okay, so which one of these ingredients or reactants decided how much I could make of my s'mores? Okay, my marshmallows. So we call this marshmallow my limiting reactant. Okay, because that is what's limiting how many s'mores that I can make in my scenario. Okay, so that's what this slide is saying. It's just saying limiting reactant is what I'm basically running out of first. What's going to limit how much I can produce? It's going to run out first. Just like I ran out of marshmallows. That means my s'mores are done, right? So basically, if we're going to calculate our limiting reactant, we do everything exactly the same that we did yesterday. We're going to, in just the same way that we did for our percent yield, we're just going to start with what we're given, calculate what we can produce, okay, and see how we do. So let's do a little practice here. We'll see how it goes. So I'm going to balance my equation first. Okay, so I've done that. And then it tells me I'm given 2 moles of sodium and 2 moles of chlorine. Okay, and so I want to know how many moles of sodium chloride can I actually produce. So the way that we do this is we're actually just going to work our problem twice. We're going to start with 2 moles of sodium, and then we're also going to work it with our 2 moles of chlorine. Okay, so if I have 2 moles of sodium, how many moles of NaCl can I make? So I'm just going to use my mole ratio, because remember with my mole map, if I start with grams, then I have to go to moles. Then I can use my mole ratio to convert to moles of my unknown substance. And then if I need to go to grams, I can. So here I'm looking at my number that's in front of my sodium. There's a 2. And I'm looking at the number that's in front of my sodium chlorine, and there's a 2. So how many moles of sodium chlorine can I make with my sodium? I can just make 2. So let's look at the next one. How many moles of chlorine? There's just a 1 for every 2 moles of NaCl. So this one allows me to make 4 moles of NaCl. Okay, so what I'm looking at is which one made the least. It's kind of like which one limited how many s'mores I could make. Okay, if I can only make 2 moles with this one, that means that I must have run out of sodium before I ran out of chlorine, because I could make more moles of chlorine. So this is my basically my limiting reaction here. Okay, so my reactant, my limiting reactant is my sodium. Limiting equals sodium. Okay, so we also have this term excess. That just means like what's left over. Just like we had extra crackers and chocolate, that was our excess. So our excess here, we're going to have some chlorine left over in our reaction at the end, because we're going to use up all of our sodium, and then we're going to kind of run out. So chlorine can only just be sitting here. Okay, so we also have just some more practice for percent yield. I'll just go through one real quick again, just so you can kind of see it again. Mama. So remember, percent yield is actual over theoretical. So if I actually produce 3.63, my theoretical amount, oh, this is where I think I have a typo and I forgot to fix. Let's change it to 1.63. So if I actually produce 1.63 moles, but I thought I could produce 2, right? And then I have to multiply that by 100. Then I get 82%. Okay, is my percent yield. Okay, let's do one more, just determining our limiting reactant. Okay, and I can balance it quickly. So we need 2 chlorines over here to match over here, and that means I need 2 lithiums. Okay, so again, I'm just going to set up our equation just like we've been doing. I'm just going to set it up twice because I'm given this amount and I'm also given this amount. So 21.5 grams copper chloride and 10 grams of lithium. Okay, so grams, remember we can go from grams to moles. Then we have to use our mole ratio to look at our new compound, and we can go from moles to grams here. Okay, so let's see, grams of copper. Grams of copper is 63. I've got 2 chlorines. So I've got about 134.5 grams, okay, of my copper chloride. And remember, that's in 1 mole. I had to convert my grams to moles before I can use my mole ratio. Now I can use my mole ratio. So I'm starting with copper chloride, and I'm looking for this lithium chloride right here. So how many moles of copper chloride do I have? I just have 1 in my equation right here. Lithium chlorine, I have 2. So now I'm in my moles of lithium chloride. I can convert to grams of lithium chloride. So I'm just going to look back at my periodic table, add up my masses. Okay, 42.35. So now I can just go through and multiply the top, divide by the bottom, because everything's canceled out. Moles, 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 moles. So I end up with about 13.6 grams that I could produce. Okay, we're not going to worry about doing this part right here for that one, for our percent yield. So here I got to do my lithium. Let me get that out of the way. So grams of lithium in 1 mole, I've got 6.9 grams lithium in 1 mole. Then now I can use my mole ratio. I have 2 moles of lithium for every 2 moles of lithium chloride. And then this last part is basically the same. 1 mole of lithium chloride, 42.35 grams. Lithium chloride, that's my molar mass to get me to grams. So when I multiply my top here, divide by the bottom, I end up with 61.4 grams. Okay, so which one can produce the smallest amount? That's this right here. So that means copper chloride is my limiting. Okay, I have extra, lithium is my excess. Okay, so all I did was I did the exact same problem, right? I can look at my foldable that I printed out to help me know my steps to set up, and I'm just plugging in my numbers. I do the exact same thing. I'm just going to do it twice with my two different amounts of reactants. Whichever one produces the smallest amount, that's my limiting reactant. It's like my marshmallows only allowed me to make one marshmallow. I could make more with my other stuff, but I was going to run out of marshmallows. So that means that whatever produces the smallest is your limiting reactant.